How are underwater structures made? Have you ever looked at a massive bridge stretching across the ocean or a tunnel running beneath the sea and thought, how on earth did they build that underwater? From high-pressure depths to freezing currents, engineers have conquered impossible challenges. Today, we're diving deep to uncover the fascinating secrets behind underwater construction. 1. The hidden challenge beneath the waves. Building underwater isn't just construction, it's a battle against nature itself. Imagine working in total darkness, surrounded by crushing water pressure, and trying to keep everything perfectly stable. Unlike building on land, underwater projects must deal with strong ocean currents, corrosion, and limited visibility. The very first problem engineers face is, how do we keep the worksite dry and safe? You can't just pour concrete into the ocean, it would dissolve instantly. So engineers use some of the most creative and precise methods in modern science to tame the sea before laying the first foundation. 2. Step 1. Site study and planning. Before construction begins, there's a long and complex phase called the site investigation. Engineers use sonar mapping, underwater drones, and sediment sampling to study the ocean floor. They analyze the depth of the site, the seabed type, sand, rock, or clay, the water currents and wave behavior, the impact on marine life. Every project, whether it's a tunnel, bridge, or oil platform, starts with computer simulations. These digital models test how the structure will behave under pressure, in storms, and during long-term use. Even a small design flaw could cause a billion-dollar disaster underwater, so nothing is left to chance. 3. Building a dry zone. Cofferdams and caissons. To build foundations underwater, engineers must first create a dry working area, and that's where cofferdams and caissons come in. Cofferdams are temporary enclosures built to block out water. They're made by driving steel sheets deep into the seabed to form a watertight wall. Once sealed, pumps remove the water from inside, leaving a dry area where workers can build foundations just like on land. For example, during the construction of the Brooklyn Bridge, massive cofferdams allowed workers to lay its foundations under the East River more than a century ago, long before modern equipment existed. Caissons, however, are more advanced. They're giant hollow boxes made of concrete or steel, sunk into the seabed and filled with air or concrete. Caissons can be open, closed, or pneumatic, pressurized. Workers sometimes enter them to dig through mud and rock, while the caisson slowly sinks under its own weight. Projects like the Golden Gate Bridge and Tokyo Bay Aqualine Tunnel used massive caissons that became part of the permanent foundation structure. 4. The power of underwater concrete. Now comes the secret weapon, underwater concrete, also known as anti-washout concrete. Normal concrete can't survive underwater. Its cement particles wash away instantly. So engineers developed a special mix containing chemical admixtures that make it cohesive and sticky. This type of concrete holds together even when submerged and exposed to moving water. It's poured using a method called the tremie technique. A long vertical pipe called a tremie is lowered into the water, and concrete is poured through it from the top. The pipe's bottom end stays buried in the wet concrete, ensuring it doesn't mix with water and ruin the strength. This technique was key to building offshore platforms, harbor walls, and even parts of the Hong Kong-Zhuhai-Macau Bridge, one of the longest sea-crossing bridges in the world. 5. Prefabrication, building on land, installing underwater. Modern underwater projects often avoid long hours of risky underwater work. Instead, engineers use prefabrication, meaning large sections of the structure are built on land and then transported to the site by floating them across the water. Once in position, the prefabricated units are carefully sunk into place using cranes and ballast systems. This technique not only saves time, but also improves quality control since construction happens in a safer, controlled environment. 6. The role of divers and robots. While technology has advanced, human divers still play a vital role in underwater construction. These highly trained specialists use special suits and breathing systems to weld, inspect, and install underwater components. But today they're assisted by ROVs, remotely operated vehicles, and AUVs, autonomous underwater vehicles, robotic machines that can go deeper than any human. ROVs are equipped with cameras, lights, and robotic arms that can cut, weld, and move heavy parts. 7. Sealing, safety, and maintenance. Underwater structures constantly face corrosion, salt damage, and water pressure. To protect them, engineers use special coatings, rubber gaskets, and waterproof membranes around joints and connections. Metals are often coated with zinc or epoxy to prevent rusting, and some parts use cathodic protection, a technique that uses small electric currents to stop corrosion. 8. Iconic examples of underwater engineering. Let's explore a few legendary examples that show the power of underwater construction. The Channel Tunnel, UK, France. Built 40 meters below the seabed, this 50-kilometer tunnel connects two nations and carries millions of passengers every year. The Øresund Bridge, Denmark, Sweden. It's part bridge, part tunnel, an engineering masterpiece that seamlessly transitions from above water to below. Tokyo Bay Aqualine, Japan. This 14-kilometer structure combines a sea bridge and tunnel system built using caissons and underwater concrete. Dubai's underwater hotels. These luxury structures use thick, pressurized acrylic glass and water-resistant materials to let guests live surrounded by marine life. 9. The future of underwater construction. The future of underwater building is even more exciting. Engineers are experimenting with self-healing concrete that automatically fills its own cracks, and 3D printing technology that can create entire structures on the seabed without human presence. Countries like Japan are planning underwater cities such as Ocean Spiral, where people could live and work below the ocean's surface using renewable energy from waves and tides. Scientists are also developing bio-friendly materials that won't harm marine ecosystems, ensuring the ocean's health while humans continue to innovate beneath its surface. Final thoughts. Underwater construction is one of humanity's greatest achievements, combining science, courage, and creativity to push beyond our natural limits. From bridges that defy the waves to tunnels that connect continents, every underwater structure tells a story of human persistence. It's proof that even in the most hostile environments, innovation can find a way. If you enjoyed this video, don't forget to hit like, share, and subscribe.